So Jean-Philippe, should we start the keynote session? Q's and A's.
Yes. Yes. Let me just get my bearings. Even because, as we all heard, localization is key. Just a second, please. All right. Well, in fact, as it seems, I'm the first in line for the Q&A. By the way, there was an issue with the uploading of at least my video. I hope there wasn't any more issues with anybody else's. There seems to be a glitch that makes every single slide that goes through repeat my welcoming message. So I guess I bored you to death by saying hello and welcome. Sorry about that. It wasn't my intention. It was something to do with the uploading of the video. So sorry about that. But if you have any questions, I think it was a very introductory presentation anyway, but I would be happy to answer.
So maybe a question. I was curious about the Semfire projects. I didn't have the idea of the scope, how many people involved, how many universities. Can you elaborate a little bit?
It's a relatively small project. It's a regional project. It's in fact, I'm giving you an answer, but probably Mikael would be the best person to do so because he is the coordinator. This is a regional, regionally funded project. It relates to the framework, to a framework that's called Portugal 2020, which you can see from the name that it actually is a backdoor to the Horizons 2020 European framework. It only, Semfire itself only relates to the University of Coimbra, with the Institute of Systems and Robotics involved, and then two different companies. So it's Engenharios, who are the coordinators, and an end user company. I think that's in fact one of the slides. You have a kind of an overview of the consortium there. But that's it. It's only 3 partners, so 3-year project, 600K more or less. K euros, of course, 600,000 euros. So yeah, small team that has to do a lot of stuff. So pretty ambitious, but I think we'll do some good work there. Of course, we have some sister projects like Safe Forest that kind of take this a synergetic approach. So eventually we'll end up helping one another to make a more substantial contribution. I hope that answered the question.
No, it does, and you know, having small teams. I mean, I think it's common of many people trying to do a lot with small teams, but at the same time, it's like I think finding the synergy is important between projects, and it's.
So I'm moderating myself. Anybody else has any questions?
So Jean-Philippe, let me ask one question then. So, what do you believe is necessary for this field to be developed and to have more investments on it?
So you are asking me the question that I'm asking everybody, right? I have some opinions about this. In particular, I think that there is, let's say that the translation between areas in robotics that is needed. So stuff that we have as, that we tend to take as granted for indoor robotics or outdoor robotics with structured environments is stuff that actually doesn't work as it's programmed to work in difficult situations or applications such as forestry. We can already see the difficulties in agriculture. In forestry, it becomes much worse, in my opinion. So what we would say that we have as technology ready levels 5 upwards in all the other easy robotics out there, in our case becomes a much more immature field. So perception, navigation, in fact, it was already pretty evident during the forestry session. All of these are major challenges, and we are still kind of grasping at straws in terms of what actually are the problems, because we keep stumbling on stuff that is absolutely unexpected, which is perfectly natural because we are dealing with an unstructured environment. I think the only thing that we find that is actually pretty structured in a woodland are the plantation trees themselves, and that's if we're lucky. So I hope, let's put this in a nutshell. I hope that I won't be the person answering that question for you, David. I hope that we have a very nice white paper at the end of these proceedings that actually takes us to a position where we can start answering these in a more systematic way, which I think is what we are missing, a systematic approach to forestry robotics, probably. We've had many very good efforts. In fact, we've had forestry robotics for some decades now. And what I think is missing is kind of a systematic approach with everybody trying to bring their ideas together. I think this workshop is particularly well focused to be a good kickstart to all of that, I hope. So let's see if everybody agrees when we get to the roundtable.
Of course, we'll disagree. We have to disagree.
Well, no, you can disagree about the specifics, but not about the big question, I hope.
No, of course not.
All right, so moving onwards from my own talk, next in line, I have Michael's talk on the rise of heavy-duty robotics, forestry robots. So, if anybody has any questions, I think it's unnecessary to be introducing people and the talks. I think we are pretty well known in our fields, but if you want to do an introduction, I won't stop you. If you have any questions, Michael, I guess you are here. Take it away.
Well, I don't have questions against my work.
Of course, but if anybody has questions, Miguel will be happy to answer.
Joel, I have nothing to add about introducing myself. I can only say that I'm representing Engineers here and coordinator of Simplification, Safe Forest, a few other projects in Forestry Robotics. And the keynote was pretty much like an overview of everyone's contributions in the project, and not only mine, but everyone that has been associated to the project. So any general questions or specific questions or technical questions, whatever you want, just feel free to ask them. And if I cannot answer, I'm pretty sure someone will.
Okay, so since I hate awkward silences, let me make a question.
Break the ice.
I've known Michael for a long time. We are colleagues for quite a few years, and we are friends, and so we know each other very well. But still, I would like to make a question which I think can bring some discussion. And so my question to you, Michael, is what would be the future plans for the company regarding heavy duty, and which kind of machines are you planning to use to keep tackling this forestry robotics area?
Okay, thank you, David, for the question. So as you know, and you know this very well because you know me, as you said, for a long time, Engineers started with a two kind of thing. I mean, we wanted robotics, and then we wanted sports technology. We want it all. I mean, we want it all, and we want it now. I mean, okay, that's totally neat, but it doesn't work. Okay, that's the reality. It kind of sucks, but it is what it is. So to be honest and see how things are moving currently at Engineers. I cannot say that I see myself exclusive to the heavy-duty robotic field, but I do see myself in field robotics exclusively. And when I see myself, I see the company as well. And we've been moving towards field robotics more and more. And currently we're working on solar panel cleaning, as you know already quite well. We worked on land mowing. We are currently working in forestry robotics. We're moving a little bit now with agricultural robotics. And this is where we want to focus at. And you know what I realized is that I sort of know that one of the answers that you were seeking a while ago, what do we need to move forward? What is needed to move forward in forestry robotics is the one I've been looking for quite a while, which are standards. We miss some standards. We need standards and we need to keep to those standards. It's not only about the frameworks. Of course, we all know ROS, and ROS is amazing, and we will keep that standard until the very end, until we are dead probably. But the thing is that it's more than that. It's about how machines work, and this is part of my presentation as well, trying to understand what vendors, what suppliers, what manufacturers are putting inside the machines, because this is one of the things that we need to attend for. We should not be constantly developing machines because we have so many robots available for R&D in the market right now, mobile robots, that it's a pain in the ass. Why do we need that much? There's already too much. What we need now is to have machines that follow certain standards. And when we have developed the Ranger all together, we decided all together to buy a machine that everyone knows, a machine that works, that we know exactly that will fit our purpose, a Bobcat in that case, but it could be a John Deere, it could be a GCD, it can be any other brand out there. And we know that those brands, they have been successful because they adopt standards, because they use specific standards within the machine, and all of them use the same. Of course that they have their own proprietary things, we all do. But this is one of the things that it's missing right now. And it's not only in field robotics, it's in mobile robotics in general. We are failing in keeping our standards. Everyone wants to have their own framework. Everyone wants to have their own sensor kits or whatever. And this is one of the things that we've changed in the company. So recently we have changed two major things in the company. One of them, we no longer have one-man army people there. We no longer have one guy dealing with one project. Now we have one guy dealing with one topic. That's it. We have one guy dealing with localization, another dealing with navigation, and so on and so forth. And if we have multiple field robotic projects, which seems to be the case, then that guy should collaborate with all other people within those projects. So this is step number one that we've been following. Step number two is exactly to try to reuse most of the hardware and software and drivers and firmware and so on that we can in different platforms. Of course, this does not work exactly as we expect it to do because robots are different. But then again, the high level should be as more abstract as it can. And to some extent, this should work for the majority of the process. If we prepare things in advance, if we prepare things to bear in mind that we're going to need different sensors in the future, even if we do not want to. So I don't know if I answered your question or not, but yeah, that's the best answer I can give you right now.
Thank you very much, Mikhail. You did.
Thank you, Mikhail. I'm not sure if there are any further questions. If there aren't, I will move on to the next speaker.
I would have a question, if I may. Hi, I'm Vladimir. From Philip Giger's floor, let's say, we share a laboratory. This is more technical. I'm referring to the previous breakout section. Can I ask a technical question here, or is it more like general scope?
Well, if you're asking the person that you want to ask the question to, I mean, it's all fair.
All right.
The only issue here is now time, because we are kind of sliding a bit. So I would ask both you and Mikhail to keep things as succinct as possible.
Yep. So it's about Google Cartographer. I noticed that you use it for localization. We were considering this for underground localization for DARPA speech challenge. I wonder what are your experience? I see in the paper that you have quite a lot of drift, which surprises me on the 50-meter or 100-meter scale. Do they do something advanced with point clouds? I would expect to the localization with point clouds to be within half a meter.
Okay, Vladimir, thank you for the question. I'm going to answer the way that I know, and then if Ahmad wants to add anything to my answer, he will more directly, since he's been the one. Oh, look, I don't have a camera. Okay, now I have a camera. Hi, hello everyone.
Hi.
I just noticed that I didn't have the camera on. Sorry for that. Okay, so our experience with Google Cartographer was not very good in the beginning, to be honest. And currently we are no longer using it as we were before. We are using it to estimate the odometry, which is feeding the robo localization framework, which seems to be way more reliable since it integrates other sources of odometry, as you probably must know. So yeah, I mean, what we observed with Google Cartographer was that we had some drifts because we were considering the odometry, the lidar odometry, and the GPS was only as differential kind of source of odometry. So we were really not using it as absolute. So it's normal that you have some drift after a while. Ahmad, if you're here and if you want to add anything to my answer, please feel free to do it.
No, you're right. I mean, this LiDAR-based odometry, this is quite accurate in the short term, but in the long term, yes, it drifts. And mentioning that in the paper with the RTK GPS, yes, we have that kind of an accuracy. So it depends upon your sensor modality, how big or how small is the error in the.
I've lost Ahmed.
Yeah,
Yeah.
Ahmad, your video froze. So we lost the final part of your answer.
Yeah, I mean, in a nutshell, I think that
I would probably suggest that you turn off your video because you're dropping off as soon as you move.
Okay. Yeah. So it depends upon the sensor modality in a nutshell.
All right.
So the accuracy.
So I see the cartographer does not attempt to make any global map. You just use it as a fusion framework for odometries. Yeah, that makes sense. Thanks.
Okay, thank you. I'll have to move on to the next speaker, and in this case it would be George Cantor. So semantically assisted SLAM in tree canopies. Do you want to do an introduction?
Sure. So you know, I've been working in SLAM for a long time. I've been working in ag for a long time. I think and I'm part of the Safe Forest project, which I think is really cool. So this is sort of an introduction to forestry for me, which is great. You know, I think the key intellectual idea I want to bring in is this idea of using semantic labels as part of mapping. So there are these really powerful tools for using LiDAR and cameras and GPS and inertial sensors to build up beautiful maps. You put on drones, you put on vehicles, build up these really detailed 3D models and then use them to localize. Those work great in environments with a lot of structure, and they don't work so great in environments where there aren't a lot of structure. One of the things we've noticed is that you can sort of add structure by adding semantics, because in these environments, you're always there for a reason. You know, if you're in a vineyard, you're counting grapes, and so we're doing grape detection anyway. Maybe we can use the grapes as features in these maps and get better. And so if you watch the talk, we give a couple of examples of that working. And then I think in the forestry case, you know, we'd like to take the already pretty successful mapping pipeline that we have and augment it for forestry by adding semantics and maybe get it even a little better and actually start to not just have a 3D model that can tell you where you are and where the other things are, but actually label what those things are. This is a tree, this is a shrub, this is grass. And then be able to use that to reason about these operations. So, I'll leave it at that and open for questions.
So if I might jump in, you said something at the conclusion, your take-home message slide, I believe, it's something about the nice interplay between SLAM and AI semantic, and then semantic feeding the SLAM.
Right.
Can you elaborate more about how do you see like the future of this tight coupling between the two fields?
Yeah, well, I wish I had an answer to that. You know, that's one of the things we're striving to find out. But you know, when you know, so you get a point cloud. Point cloud's really hard to interpret. You project semantic labels on it, and it becomes easier to interpret it. Those labels can then help you register the point cloud better, and you can turn around and make an even better point cloud with the labels. So that's kind of what I meant by the back and forth there. You know, eventually, I think that AI needs to move in a direction where we're operating in these 3D environments, and we have models of everything in the environment that's not just semantic, but has sort of prior knowledge encoded into it. Like, so, I don't know, in a simple version, if you're on a factory floor, you might drive through and see things and have CAD models associated with those things and be able to automatically infer what's on the other side you can't see because you looked up in a library and you knew that there was a handle around the back you could reach to or something like that. And so I think that, you know, this applies as you get into more and more unstructured settings. This becomes more and more important because the sort of human knowledge that we have about what's going on in the scene really informs the actions you want to take and the inferences you want to make. And right now, we don't really have ways of doing that. You look at a point cloud, it's like, okay, as a smart human, I can look at it and say, oh, that thing that looks like a cylinder, that must be a tree trunk. And so if I want to place my in situ sensor with my drone on that, I should go there and do that. But we don't have all of the sort of high level intelligence to make those decisions seamlessly.
Thank you.
Okay, I have a question. I watched your lecture and you were talking about using known geometry, for example, for grapes to overcome point clouds. And in case of the Safe Forest project, which is, from my understanding, mostly LIDAR, how would you do that in a dense forest environment where the geometry is not as cut and clear as with grapes, for example? Yeah,
so that's a very good question. And my hope is that we see enough things like trees. So trees make good, like the cylindrical trunks of trees, I think should make good features, right? And if I can, right now, you know, the way the LiDAR algorithms work is it's all just raw point cloud matching. So in my prior map, I have just sort of a point cloud, unlabeled point cloud that's a cylinder. I get my new map, it has another cylinder, and I kind of force them together. If I can semantically label both those things, I can do that matching a little bit better. The short answer is I don't really know what features there will be. The other thing is that I would like to, over the longer term, get away from manually engineering those features, right? So in the grape case, we said, oh, grapes are round, we can fit a round thing to them and they'll make a good feature. It would be really cool if you had like a library of different shape primitives or something where you could recognize these shapes, pull out these compact representations of them without a person having to say, oh, that's a tree, it looks like a cylinder, let's fit a cylinder to it.
Okay, thank you.
Any more questions? I'm feeling a great roundtable coming up, I have to say. Yeah, it's in the air. All right, so I'll move on to the next speaker. And that would be Philippe.
I'm going to try to share my screen. I'm very. Oh, is it possible to share my screen? Because I see it's disabled for participants.
Can you help us there?
Yeah, let me figure that out.
It's a very short presentation. It's just easier to think it's.
How can I do this? Let me see. Share screen. Advanced sharing options. Okay, participants.
I will be counting down time for you.
Okay.
Oh yes, got my time.
Go ahead. Should be possible now, no? Right?
Okay, there it goes. Share screen. I don't know if you see my screen there.
Yeah.
Yes.
Good, excellent. So as was requested, we're asked to present ourselves. So will not present myself, I'll present rather the lab. So the Nora Lab is a lab, was founded in 2017 by François Pomerleau. And I joined instantly his lab because he's a very fantastic researcher and is a fun person to work with. And basically our target research area is mobile autonomous systems working in northern and difficult outdoor conditions. They say when life gives you lemon, you make lemonade. We have lots and lots of snow. We have about 6 months of snow coverage. Back home, maybe 8 months if we go in our research forest north of Quebec City. So we have plenty of place where we can try algorithms. And you can see actually one of the robots we have in the lab. It's Warthog equipped with basically tracks, so we can be able to navigate in the snow, somewhat easily. And some of the ongoing research we have, basically very important. François is really doing navigation and LiDAR mapping, 3D mapping, so that's his bread and butter. I'm more about 2D and 3D perception. So some of the project that François is doing and myself sometimes. So for instance, for François, he does a lot of 3D mapping in cave or forest environment because those are very challenging. And actually, Vladimir was asking a question earlier, was part of the DARPA Sub-T challenge where they tried to both map and navigate and find particular objects in underground environments. That was a DARPA challenge, and they actually had very good success. I think they ranked in third from all the teams. Also, François developed the Lib Point Matcher library. So Nora Lab is now the home of of this library, which is used by a few people. Obviously, navigation control in winter environment is challenging, therefore very interesting. So we look at that as a lab in the forest, but also for public transportation purposes, because our self-driving bus is going to work in Quebec City with the amount of snow we have. We also work on grasping for difficult objects which are transparent and metallic. So again, this topic of going into pushing the limits of existing algorithms. And finally, the projects which I'm spearheading is the automation of basic forestry operation, tree felling, and forwarding. And on this, I will stop this sharing and I'll be welcoming your questions.
So there you go. A very professional introduction, and we are open for questions then.
I have a really boring one, if that's okay. On the issue of tree felling, how do you deal with the safety of personnel around the robot if you're felling a tree as an experiment? What sorts of hoops do you have to jump through in order to have that be a successful mission?
So it's a very interesting question. I had the chance to go and visit a research lab in Sweden, and forestry is not the same around the world. Forests not only they're different. Like in Sweden, for instance, the forest they tend to be well maintained. There's not a lot of visual obstacles and not a lot of undergrowth. Whereas back home, the forests, unless it's commercial forest or private forest, most of them are just it's the wild. You go there, you got you got the cutting right from the government. You pay your stumpage fee, and you go and you cut the trees. And in Sweden also, people have the right to walk anywhere in forests. Okay, so for instance, in the Swedish, they have the Auto 2, I think it's called, project, where they actually, one of the big component is actually people's safety, because at any time somebody can pop out into the area where you cut trees. So safety is very important in that situation. I would say back home, you have no business being near a felling machine. And it's because if you're a human operator, they're so focused, the amount of operation they have to do mentally to operate these machines. And not only that, I think we had some researcher in our university, they put cameras, and the people sometimes actually fall asleep because they're cutting wood round the clock, and they work for 10-hour shifts, and they fall asleep at the machine. So even a human cannot guarantee the safety of other humans around. So I would say that it is not an aspect we're looking at. We're looking really at the perception aspect of, okay, I just want to know where to cut the trees. We kind of leave the safety aspect for others. Maybe the Swedish will solve it. Maybe it's somewhat of a non-issue where we are because of the amount of space we have and the fact that nobody's going to walk in the forest randomly like 400 kilometers north of a city. So it's a bit less of an issue. But definitely, you can use things like neural networks, cameras, and look around. But for now, I know, as was mentioned before, we're a small team. We have to limit ourselves, and I think without stepping too much. Huh? I'm sorry.
Pick your battles.
Yes, choose your battles. Very important, choosing your battles, and I lost my train of thought there. Yes, sorry, I lost it.
I think I got what you mean. Just go far enough into the woods, and it's a non-issue.
It's a non-issue because it's surprising, but forest and maybe Siberia also, but there's cases where people have stepped out of a trail and died because they couldn't find their way back to the trail, and it's worse than being in the desert because you'll die of hypothermia. And
Philippe, I would say it's not that surprising. I mean, my wife is an agricultural engineer, so she owns a couple of woodlands, and the amount of people that we know that have severed limbs and stuff like that. I mean, it's pretty amazing how dangerous it is. So even humans haven't solved it.
Yeah.
But still, I think it's an important issue to keep in mind. I personally, within the scope of projects such as Safe Fire or Safe Forest, I'm really conscious of the fact that we have these massive machines. When I look at the ranger and see it mulching, even with a human operator inside, I get a bit jittery. It's impressive and it's frightening at the same time. And it's important to keep track of every living, moving being that's out there. So yes, I think that will be one of the safe operation would be on one of the issues that we will be talking about in the roundtable for sure.
Yeah, I'll just continue there then. Maybe that's for the
other questions.
But that, just to jump back, it might be a key difference between agriculture, where it's more of an urban area where you actually have other workers and you have this concept of human-robot interaction, co-robotics, which working at least in northern Quebec, it's a very lonely job. You're there and all you do is cut trees.
Well, in Safe Fire, we are, and I think in Safe Forest too, we are, because of the autonomy question and the fact that we have to focus a bit, so pick our battles, we are counting on the fact that we have autonomous operation for 3 phases and the rest of it is overseen by a foreman, and probably we'll have the robots cooperating with a human team. So that's where our end user comes in. And probably the mulching that the robot will be able to do is the main course of mulching, whilst the fine, how did you put it, Philippe? You said you used a perfect word for it in the previous session. Manicuring, yeah.
Yes.
The manicuring side of it will be done by humans.
Yeah.
So in that case, we are very much aware that there has to be some kind of safe operation. Of course, for now, we are just thinking about deploying. The robot will do itself. The team will do itself. Come back. That's it. And now the humans can come in. So it's a very controlled situation, but still it's something that we have in our broader horizon, so to speak. Right.
One more thing, I got it back. What I lost is we're also not aiming for full automation. We're aiming at reducing the cognitive load of an operator. So my feeling is the roadmap is for the next 5 to 10 years, instead of having two joystick 12 buttons, is you have a screen and guy just tap the screens. Okay, here are the trees I'm going to cut. He's still watching over. But what we did is we reduced the number of cognitive tasks by a factor of 90%. Actually, he has more time to look around to see if there's anybody walking. So if anything, that would help the safety of the system.
Miguel David and I submitted a project a year ago that was we nearly got there for Horizon 2020. It was we were above a threshold, so it was by this much. But anyway, we were already thinking about that next step. Yeah, I feel that that's something we have to deal with too. But again, roundtable, please. Okay. So, any more questions for Philippe concerning his current talk, not the future?
Yes. Let me ask one. It's a yes or no question.
Oh,
so that's an easy one. Philippe, I saw your paper, journal paper on I think it's the agriculture journal, the one from Elsevier. And so you had a work on mapping a forest. And my question is, do you have that? So I understood you use a machine with ROS with multiple sensors, 3D LiDAR, stereo camera, IMU, GPS, etc. So my question is, do you have these data set, and is it open, and can you provide it?
There's 2 journals papers that we have for mapping, so it'll be more than yes and no. One I don't think we have because it was at Nibio in Norway, but the other one we definitely have the data, including the ground truth of 3 diameters. And we have about 55,000 LiDAR scans with basic sensor data. So this is available. I can point out to you where to find it. But yes,
that would be great.
I'm going to send you my email address privately.
Right. So let's stop here. Sorry, Philippe, you had a lot of interest there, but I think it would be now a good time to move on to Sunjo Chung's talk. So learning-based planning and control with uncertainty, nonlinear, stochastic dynamics, and chance constraints. Are you there?
Yeah, I'm here. Thank you. Hello, everyone. Just about myself, I'm a professor at Caltech. I'm working on aerial robotics, spacecraft robotics with a specialty on like guidance, motion planning, and feedback control, nonlinear stability. I do work a lot on formation flying spacecraft and so on, but I do have an active program how to combine machine learning, AI with control theory, motion planning. For this workshop, I have a few related paper. Maybe that's why I think I'm invited, but I didn't talk too much about that paper in the video. That's a 2015 International Journal of Robotics Research paper with Seth Hutchinson. I was actually on the faculty of the University of Illinois for 7 years before I moved to Caltech. So that paper talks about how we can fly aerial robot fast in a forest, obstacle-rich forest, with some combination of vehicle dynamics and some optimal control. I do have some papers in a SLAM. I had a grant with Seth Hutchinson when I was at Illinois, funded by Office of Naval Research, basically a SLAM in a riverine environment where you can have some overhanging canopies, trees, but the key idea was to basically use the reflection from the water, so a combination of vision and no LiDAR. And so I have 3 papers in that topic published in Journal of Field Robotics. One is on segmentation, the other one is SLAM using reflection, and the third one is actually stereo, basically SLAM using line of curves. Basically, you can create the map based on the shorelines or river lines of the river. So that's why we need the segmentation. I heard a lot of some conversations on multi-robot systems. So I was a guest editor. I'm currently associate editor for Transactions on Robotics at IEEE, and I was the guest editor for a special issue. I actually downgraded to special section on aerial swarm robotics, published in Transactions on Robotics 2019 or 18. So you might want to check that out. Yeah, and I think some main thing that I wanted to introduce to you was some recent results from our group, motion planning, where we combined the learning method with some of the motion planning method. When in particular, I've been working on some real-time motion planning using optimal control, assuming that you have some vehicle dynamics. So this is maybe more relevant to aerial robot, where you might have to use some, at least vehicle kinematics, but oftentimes even vehicle dynamics. I think it could be true when you have a ground rover moving in a 3D terrain. So maybe you might have to use some dynamics information. I saw some talk that you are actually including dynamics of a tree. In that case, actually, you might want to use, instead of using just like RRT and so on, you might want to actually use some optimization or optimal control-based method, including dynamics. So my recent method published in CDC and RAL, actually, we can use a nonlinear dynamics with a stochastic noise. So basically, it's a stochastic differential equation. So optimal control using stochastic differential equation, it might be actually a challenge. So we actually turn the nonlinear dynamics with the noise into the some deterministic dynamics using the generalized polynomial chaos. And what if we talk about SLAM? What if you have a huge uncertainty when you map the environment, terrain, or like basically trees? So you might actually, I mean, in any motion planning, you have a constraint, right? Collision avoidance constraint, a vehicle control input constraint, and so on. And you can actually use the probabilistic constraints. So this is a chance constraint. So some of our main papers present some method that can handle both probabilistic constraints, either coming from the sensor or even vehicle uncertainty, vehicle dynamics uncertainty, and also nonlinear stochastic dynamics. And also my recent paper with my student also talks about how you actually combine the deep neural network, deep learning, with motion planning, especially multi-agent systems. So that could be also applicable to single vehicle. Basically, we use the imitation learning to train a lot of expert demonstration. So actually, we use the imitation learning. And then we combine that with a local feedback control or using, and also safety filter, barrier function. And then you generate a lot of expert data using basically simulated environment, and you get the solution from some optimized optimal motion planning. So we use our prior work using sequential complex programming. So that's actually a paper called the GLASS. So that might be of interest to you. And what else?
Well, so if I may, probably people will be prompting things from you as soon as they get a chance to ask their questions. So I would probably, even because we don't have that much time,
right,
ask for people to shoot away. And I'm sure that you'll have some nice questions coming in.
Thank you.
Philippe?
So if I'm asked maybe a high-level general question, I mean, there's people who do like traditional robotics, and there's people who do deep learning. And then there's this concept that, you know, deep learning is eating software. I think there was a presentation from Tesla where they basically have this traditional block diagram of self-driving car, and it says as soon as we can replace a block with deep learning, we do it. And then it's sort of like their goal is kind of like to transform everything as a big network. And you're doing traditional robotics, and you're doing also deep learning. What is your feeling about that?
Actually, I have that exact diagram. If you look at my talk, I have this block diagram where it's conventional feedback control, like a diagram. You have a dynamics plant, estimation block, feedback control block, motion planning block. But then I kind of emphasize what's the load of learning or AI and so on. I mean, maybe my answer is a little convoluted, but let me try to get there. So I think let's go back, talk about the feedback control first. We have some multiple results where we try to combine the deep neural network with feedback control. I'm an original nonlinear control person, but the problem is that it's like a black box. You can use the AI or deep neural network to actually learn some unknown model, right? So once you have a better model, you can actually get a better control result. I mean, you know that, I mean, at least, you know, if you know the nonlinear control theory, I mean, you can just cancel whatever learned model, whether that's the additional disturbance or unknown model that you didn't take into account in the original dynamics. So we do have that kind of model approach a model-based approach. So we don't start from scratch. So we use a deep neural network to add additional like a modeling. So that's actually applied to drone control. So I have multiple papers. One prime example is actually if you type the Google neural lander. So we apply that to drone landing control because, as you know, if you land a drone, there is a additional aerodynamic disturbance called the ground effects when the drone approaches the ground. So we actually do a lot of training to model that, and it can improve that. And then we combine that with a nonlinear feedback controller to show the improvement. The problem is that if you just use a deep neural network, you don't really predict what's going to be the output of your model when you go beyond the training domain. So we have a special technique called the spectral normalization, which is actually a fairly well-known technique. But we basically, when you do this like a stochastic gradient descent and so on, you actually get the basically Lipschitz constant of the whole neural network, Jacobian, basically slope of your neural network, so that you can make sure that it doesn't exceed this basically desired value, let's say 1. Then you can use that information to truly prove the stability of your nonlinear controller that has this black box AI deep neural network. So it's actually called a neural lander, and with a spectral normalization technique used for the deep neural network. And we can show that if your drone goes beyond the training domain in the sense of the height and vehicle state and orientation and velocity and so on, you can actually see the smooth transition, and also it's a robust, and we can guarantee some robustness. So what I'm saying is that when you combine the AI and deep neural network with conventional method in estimation theory and control theory and so on, you have to make sure that it's safe and interpretable and robust. And we have a certain techniques we are looking at. So that's one of the focus areas. In terms of motion planning, I talked about feedback control. We can also add a learning block to motion planning in the sense that I mentioned the earlier motion planning with optimal control approach. Obviously, your motion trajectory or control trajectory optimal or satisfy the constraints, assuming that your model, whether it's a dynamics or obstacle model, accurate. But what if you have an error there because of your state estimation is incorrect, or your situational awareness about the terrain or obstacle is incorrect? So while you are computing your optimal motions or optimal trajectories, you can learn you can improve your model based on the additional sensor information you collect on the fly. So it's actually called you combine this safe exploration with the learning. So we have a paper in that. So basically, while you're moving around, you add additional cost function in addition to conventional cost function of maybe minimizing the control effort or minimizing chances of colliding with an obstacle. And you just add additional information cost, so that basically it's a trade-off. Like it's like almost like an exploration and exploitation trade-off. So you have to move around to get more information to improve your machine learning performance, or at the same time you want to minimize the certain original cost for your trajectory optimization. So we have some paper basically looking at that trade-off. But at the same time, eventually it all comes down to stability theory. We may make sure that if you add a machine learning, a deep neural network for control, deep neural network of motion planning, or maybe use some CNN for perception-based estimation or navigation, we ensure some stability by borrowing some tools from the nonlinear stability theory, nonlinear dynamics, and so on. So we tend to do some more rigorous approach in that sense that we want to duly take into account this big uncertainty we add to handle or estimate the uncertainty. So that's what I'm talking about, is basically deep neural network or CNN you add to your estimation or control design. So yeah, so it was a kind of long answer, but my point is that we should be careful about the the ramification of adding this deep neural network to control and motion planning, and sometimes also estimation. And then we have some techniques that we can use to guarantee the robustness.
Long but very interesting answer.
I completely agree. Thank you very much. Any further questions? Okay, it seems.
Thank you very much.
Okay, so it seems there are no further questions. So I think the long answer was so interesting, it covered everything. So thank you very much. We should move on to the last speaker, who would be Yael Edan. I hope I'm pronouncing this at the very least in a way that the speaker can understand what I'm saying. And the presentation is Robotics Harvesting, Lessons Learned from the Crops EU project. So please introduce yourself and
okay, then
we'll ask questions.
I'm Yael from Industrial Engineering, Ben Gurion University, the Agricultural Biological Cognitive Robotics Initiative. We've been dealing with development of agricultural robots for over 30 years. And what I tried to present in my presentation is really a summary of several lessons learned. And I think we can really transfer over to the white paper very strongly. So I'll kind of jump in between because I assume you saw the presentation. We basically focused on and have developed a lot of different approaches and algorithms focusing on intelligent sensing and grasping. And overall, if you look into the history of agricultural robotics, and again, developments have started there in the late 80s, early 90s were the first systems developed, and there's still no commercial system really out there for harvesting. Okay, so the research there, and I think that's probably one of the main problems, the research there started bottom up. We wanted to prove that we are able to solve the technical problems, and everybody came up with intelligent algorithms for sensing, for grasping, for the most critical elements of the robotic system. However, and I think this is really a nice transfer over to the white paper, and it links also to what was said before, there was really no systematic design. And everybody came up and there's very few papers, and we have a review paper on that. There was very few papers that at all dealt with the design, okay? And in most, there was no systematic design. And this is what is lacking. And also, building on what somebody rose beforehand, I think maybe in the break room, there's a lack of standards. So everybody comes up with this great algorithm and has great success. But okay, so what do we do with all this know-how? How do we pull this together? And I think there is a real great opportunity of forestry robots, which are really at the start of the development, but at an excellent timing, because there's a lot of technology out there. In agricultural robotics 30 years ago, we were developing on small PCs, heavy detection, image processing algorithms, maybe too far into the future looking into. But we really should look into systems engineering. And when I'm talking about systems engineering, it's not only of the robot, it's also in agriculture of the crop, okay? And this was probably one of the major lessons learned, in which we prove that you cannot, and that's the standard in manufacturing. You don't take a robot and throw it into the manufacturing floor. You do optimization. You do optimization of the whole floor. You do optimization of the task, okay? And this, until recently, has not been done in agriculture. And I think this should be a first step in forestry. Let's see how we design, I wouldn't say the optimal forest, okay, but how we take this into account when we're starting to introduce the robots. We also should link the sensors into the task, into the robot, okay? Because depending on the sensors, whatever you call it manucuring the...
Philip, you'll have a copyright coming
you have to do IP on that. but you have to take into account the sensors and the reliability of the sensors, the accuracy of the sensors, because you can design it. And I gave an example, I think, in my presentation. You can design an excellent gripper, but it will work only if you have plus minus 1 centimeter, but you don't have plus minus 1 centimeter. You have plus minus 5 centimeters. You need to design a different gripper. Okay, so all this has to be taken into account, and I think there's really a nice opportunity for such a white paper, because we can go now from top down and not only from bottom up, which was the case in agriculture with a lot of great research. And in order really to succeed, you need to simplify the task, enhance the robot, and there's a lot, and we heard in the previous presentations, there's a lot of technology out there in order to enhance the robot, but you can also use simple solutions, and we discussed some of that before. And last but not least, but it probably should be first, define the requirements and take into account the requirements a priori. Take into account the definitions from start. And I think this is very, very important. I went through in agriculture and I showed how very simple modifications in simplifications of the task can improve performance. And I think one additional issue that I would bring up, and it came up here, is that, and in forestry even more than in agriculture, bring the human in the loop. Okay, so we should discuss and deal with how can you simplify the whole robotic system by just having human-robot collaboration and taking into account that you're not developing something that is fully autonomous. Okay, you anyway will have the human there, so use this human and define where do you use this human, when do you use this human, how do you reduce the workload from the human. So if there are any questions, I'll happily, and if not, I think we can.
I would surely have many questions for the roundtable myself personally, but I'd like to see people from this room now asking questions about the presentation. So if you have any questions, please shoot now.
I just would like to say that Yael is completely right. I mean, that's why I talked a while ago as well about standards. I mean, standardization is the first step in the ladder. The problem is that, and as Yael was saying, we have that in factories. Yes, but we have robots in factories for decades now. And the application domain is like the opposite. You know, it's like we have structured and known environments in factories. This is a big difference. We have very defined protocols, very defined tasks, even for the human labor. And while in forest, everything seems to be way more chaotic, even for the human labor itself. It's very different what humans do in the forest than what humans do in factories. So it's way easier to have standards in factories right now, and people are talking about Industry 4.0, and we have Industry 4.0 in factories, that's easy. But in forests, we're like in Forest 1.0, not even that. We're far from having the same readiness level that we have in factories. But this is exactly my point. I mean, we need to start collaborating all together to create those standards and follow them. This is exactly what we should do. Definitely that. I completely agree.
Note to self, remove slide talking about Forestry 4.0 out. Okay, so I'll change that one. Any more questions?
Maybe, first of all, I really enjoyed the view that everything is a holistic thing. You know, it's like you have to design your fields, maybe breed the proper plants that will work well for, you know, robotics friendly. You can buy seeds online, robotics friendly, you know, green peppers. But maybe it's a philosophical question or society questions. In the end, doesn't it sound like the end of the family farms? Because if you have this, let's say Amazon moves into the farming industry, they'll establish their own standards. They'll have hundreds of fields everywhere. They'll collect a lot of data, which will facilitate the use of these machines. But also, you know, they will be able to buy a few machines, very expensive, that might do a lot of work 24 hours and then move them from field to fields. But a single farmer cannot afford 3 of these machines. Maybe they can rent them once in a while, but then again, he doesn't have the know-how to actually plant the fields such that it would be easy to work with the with the robots. Isn't that like maybe like a romantic aspect of me is like, well, this is the end of the family farms then. It's because we have to sort of like
the economics for agricultural robots, and again, there's very few papers that have dealt with this at all. Okay, the economics for agricultural robots are that it's not really for the individual farm. You're talking about advanced farming systems, advanced greenhouse systems, big fields. This might be, by the way, a difference between forestry robots and agricultural robots, the economics, because in agricultural robots, you're talking about a very, very low cost product. And as somebody mentioned before, yes, in both cases, the environment is unstructured. In forestry, you have a more kind of structured object than in agriculture. But in forestry, you're talking anyway of expensive machines, okay? And you're talking just to upgrade these expensive machines, but you're talking about an expensive machine. In agriculture, you're not talking about expensive machines on these small farms. So if you want to introduce, yes, definitely, you're talking about introducing robotics into big farms. And I would say this as part of the requirements. This is really one of the assumptions that you must take into account.
If I can add something, it's like Philippe. I don't think that the fact that we're going to have workable machines doing the chores in agriculture and other domains, that this will actually be bad for the small guy, because the problem is that we are no longer having the small guy. Besides the rural abandonment, because many people are giving up on agriculture at all, and forestry the same. And we've been talking about forestry robotics here, but let me generalize this. It's heavy duty applications. People are running away from them. It's like construction. I mean, okay, a completely different example. I've been constructing my house and the facilities of the company for the past 5 months. I struggled to find people to work in construction here. While 20 years ago, it was so normal. Everyone was into construction. Now we don't have people in construction. So yes, we need machines. In construction, we need them to create our own houses. In agriculture, we need to have food. In forestry, we need to clean the forest because no one is available. So I don't know. I think machines are inevitable and they will eventually ultimately save us or destroy us. Who knows? I don't know.
Again, talk about communal robotics in forestry robotics, because I think that might be interesting for the round table. But still, we are already going towards the round table, and I wish we had a coffee break just before that, because I see things warming up already. Motors are running. So do we have any more specific questions for Yael?
I wanted to drive a point, not necessarily a question. I don't mind waiting, but hey, I might as well.
Let's do it. The last point.
Okay. About agriculture and the little guy. I'll make this as short as possible. I love telling stories, but I'll keep it to a minimum. I'm from a town where you can climb on top of the castle and see for miles, and you can see farmland. It's mostly farmland, and it's split into these individual plots. And each of them is farmed by an individual. And they use these round, these large things for irrigation that go in a circle, exactly. So you see a field of circles and like 60% of space is wasted. So the little farmer is a selfish person. The little farmer takes land that everyone needs, everyone in the planet, I mean, needs, and then goes and makes minuscule circles in it and then calls it their own and then grows some grapes and then complains that supermarkets won't buy them. So I honestly think that the future of agriculture in particular, forestry maybe, is in massive massive investment and massive infrastructure. And we as roboticists, or maybe you guys as roboticists and me as a guy, need to maybe think less in terms of the little guy and think more in terms of how can we build solutions that will enable us to be sustainable in a longer term, because we'll eventually run out of food. And
Rosal, you just drove a stake through any romanticism in this session. Philippe, I'm sorry. It was going so well.
sorry about
I'm leaving. Bye. It's just...
Right. May I suggest the video? I don't know if you think this is feasible. Can we do a small coffee break and then return for? Yeah, everybody's already shaking heads. And then return for our final stint with the roundtable.